All and a very warm welcome to the session. So happy to meet you all back in this awesome session. So today we are going to learn in detail about the Ramachandran plot. Yes, so Ramachandran plot, several questions have come in the past. It is a very potential topic for you to prepare for your CSIR NET examination. Yes, because as I told you, several times several components has been asked, and still it serves as the golden topic. Also it is going to be a basic. Okay, so with this base only you can do further analysis. Even if at all you are working with bioinformatics also, this Ramachandran plot is going to serve as a core basic. Okay, so that is why you should never forget the basic components. Yes, Sandhya, yes, Ram Prabha, very good morning, and so happy to meet you all back in this session. Okay, nice, fine. So this is going to be, yes, Rashmita, yes, Ankita, very good morning all. So happy to see you all back. Fine. So before beginning into the Ramachandran plot, we will just have a look at the basic structure. Yes, Pavan, yes, Sakshi, good morning all. Right, yes, Pallavi, very good morning. So this is going to be the basic structure of your amino acid. Okay, right. So your amino acid, as the name suggests, yes, Sheetal, it is going to contain a amino group as well as a carboxylic group. That is why it is called as amino acid. Okay, right. So what do you mean by a peptide? A peptide is nothing but, yes, two or more amino acids. Okay, so two amino acids or even more amino acids, they are going to come together and they are going to form a bond. What kind of bond do they form? They form a peptide bond. And what is the nature of this peptide bond? It is going to be covalent in nature. Okay, right? Yes. So what is an amino acid? Your amino acid is going to contain a amino group and this acidic group. Okay, and two amino acids minimal, even greater amino acids, they can also come together and form the peptide. Okay, right. And what is the nature of the peptide bond? The peptide bond is going to be covalent in nature. Okay, so you could have noticed that often a carbon atom will be named as a C alpha. Have you ever thought why this is called as the C alpha, or you call them as the alpha carbon atom? Majority of the amino acids, you call them as alpha amino acids because they have this alpha carbon. What do you mean by this C alpha, and what is the difference between this C alpha and this C? This is a carboxylic acid C, but this, yeah, absolutely, yes, Ankit. So this is going to be a carbon that is going to be called as the first carbon. It is called as your anomeric carbon. This carbon is only going to form the glycosidic bond. Apart from all that, this is what it is attached with your amino group. Okay, yes. So whichever carbon is getting attached to your amino group, it is what is called as the C alpha. Why this C alpha is very important? Because whenever we are going to study the bond angles, okay, the bond between C alpha and N, C alpha and C, these are all very important. And between C and N, yes, all these are going to be very important. So that is why I just wanted to highlight what is this C alpha. The C alpha is nothing but it is going to be the carbon, yes, and that particular carbon is going to get connected with your amino group. This is what is called as your C alpha or the carbon alpha. Right. So as I said, the peptide bond that is being formed between any two amino acid. So which two groups are going to react? Yes, which two groups are going to react whenever a peptide bond is going to get formed? It is going to be your C double bond O and N. Okay, yes. So that is why if at all your two amino acids, they are going to form a bond. So between which groups the bond is getting formed? Between C double bond O and NH. This is what is called as a peptide bond. This bond is only going to be covalent in nature. Yes, Alisha, very good morning. So happy to see you all back. Yes, Ramprabha. So see here carefully the structure. We have this C alpha here. We have this hydrogen here. We have this COOH. We have your NH3 plus, right? And then we have your R group. This is going to react with one more fellow. This is going to be the COOH. This is going to be your C alpha. And this is going to be the R and H and NH2 for instance. Now between these two a bond is formed by sending out the water molecule. So whenever a peptide bond is formed, okay, so whenever there is going to be the formation of the peptide bond, what will happen? Whenever a peptide bond is formed, water is going to be sent out. Okay, so your C double bond OO and NH2, it is going to become C double bond O and NH. Okay, so your COOH and then your NH3. Out of that, from here your OH is sent out and from here your H is sent out. So this is how the bond is getting formed, C double bond O and NH. Got it? So now it is clear to you what is a peptide bond. Okay. Now if you carefully see, there are different adjacent residues and they have the 3 covalent bonds. These 3 covalent bonds, it is named as number 1. This is what is called as the torsion angle. The angle that is formed between these 3 bonds, it is what is called as the torsion angle, or you call them as a dihedral angle. Okay, so what do you call them as? You call them as a torsion angle or you call them as a dihedral angle. Okay, right. So these are the common names. Okay, so what are the torsion angles or dihedral angles? Shall we repeat? Come on, everybody. So the torsion angles or the dihedral angles. So these torsion and the dihedral angles, they are nothing but they are going to be formed between your amino acids. Okay, so this is what is going to be the different angles. Number 1, it is called as the pi bond. Number 2, it is called as your psi bond. Sorry. Oh my God. Okay, just a minute. Okay, the slide is gone in a moment. Okay, so it is going to be first your pi bond. Yes, it is going to be the psi bond. Yeah, and the third one, it is going to be this omega bond. These 3 are called as the torsion angles. Okay, or they are called as your dihedral angles. Okay, so what do you call them as? You call them as the torsion angles or dihedral angles. It is going to be the pi bond, psi bond and then omega bond. Among these 3, these 2 are only considered to be much important. Yes, I'll tell you the reason also, don't worry. Because you see that this third fellow is there, no, this omega bond. This omega bond, it is too rigid. Okay, if you are too strict, you are too rigid, anybody will come near you? Think and tell me. You are becoming too rigid. You are very hard. So nobody will come near, isn't it? Yes, you must be little bit flexible such that everybody will come to you. Got it? Yes. So this omega bond, it is too rigid. It is like a partial double bond. Yes. So it is going to become a partial double bond. Which bond? Your omega bond. And how is this omega bond between where this omega bond is formed? It is formed between the carbon as well as the nitrogen. Okay. So this is what is called as your omega bond. So when or where your omega bond is formed, it is formed between the carbon and the nitrogen. This is what is called as the omega bond. This omega bond is very rigid. It is making them as a partial double bond. Got it? Okay. The next one, it is called as the psi bond. What do you mean by psi? Psi is very boring, isn't it? Yes. So this bond, it is formed between C alpha and C. So where the Psi bond is formed, the Psi bond is formed between C alpha, yes, as well as C. This is what is going to be the Psi bond. Okay, so now you got what is going to be an omega bond and what is going to be the Psi bond. So this Psi bond is formed between C alpha as well as C. And what is this pi bond? This pi bond, it is formed between C alpha and N. Okay, so the C alpha and N, it is what is called as the pi bond. These three are called as the dihedral angles, or it is called as torsion angles. It is what is going to make up your Ramachandran plot, and minimum you require 2 amino acids to participate such that they will form a peptide bond between them, and this peptide bond is what is going to give you a dihedral angle. You are going to measure the dihedral angle and then you are going to plot it. So everybody got clarity on what is a pi bond, what is a psi bond? I am going to randomly ask you questions, you are going to tell me. Yes? Everybody is ready for it? Randomly I will ask you questions. Okay, say true or false. Okay, right. So, psi bond, it is formed between C alpha and N. True or false? Make it fast, put it in your comment box. C alpha and N, it is called as the psi bond. True or false? Yes, Ash, very good. Yes, Ramprabha. Yes, Aishi. Good. Yes, Reshmi. Fantastic. Yes, Awashish Abdullah. Superb. So this is not going to be a psi bond. So your pi bond, yes, Shashi. Very good. This pi bond, it is only going to be your C alpha N. Okay. And what is your psi bond? Your psi bond is going to be your C alpha and C. Okay, right. And what is going to be your omega bond? It is between C and N. True or false? Omega. It is going to be a true statement. Omega is always formed between the C and the N. Okay, right. Fine. So now you know the different angles between your amino acids. Which method is going to, yes everybody, fantastic. This is a true statement. And which method is used helping you to find the angles? Which experiment will help you to measure the angles? Now you know that these many angles are present. Okay. Which experiment you will use to measure these dihedral angles? Which method you will use? So you want to measure the dihedral angles, correct? Which method you can use? It is a tertiary structure, correct? So which method you will use? Come on, make it fast. 2 methods are prominent. Okay, number 1, it is going to be an X-ray diffraction. Very good, Ramprabha. X-ray diffraction, or else you call it as an X-ray crystallography. Yes, it is a majorly used method. Yes, Ash, very good. So the minorly used method is going to be NMR. It can be used for the proteins up to 100 amino acids. If the size is very big, beyond it, you can never use it. Okay, but till now you can definitely use this NMR. Okay, yes. So this X-ray diffraction studies as well as your NMR, it is going to help you to predict all the bond angles. Okay, so based on that you can find out the angles. Accordingly you will be utilizing them. Got it? Yes. So this is how your peptide bond looks like. And how is the nature of the peptide bond? It is planar, isn't it? And one more question. This peptide bond, can it form in the main chain or it is applicable for the side chain? Think and tell me. It is applicable for the main chain alone or for the side chain also it is applicable? For side chains also you can do it? Never. You can do it only for the main chain. Side chain you cannot see. Yes, Harvinder. So it is going to be only for the main chain. Yes, main chain alone your Ramachandran plot is functional. Side chains it is never functional. Got it? So now it is clear to you. And this is going to be your pi and the psi angle. And this is your C double bond O. It is original bond. And between your C and N, this bond between C and N, this is going to be omega, and it is going to be a partial double bond. Okay, so this is how different amino acids it is being linked. Can you see? This is one amino acid. This is amino acid residue number 2. Yes, they are all linked with each other. Can you see that? So, and also one more thing you can see. This R, it is coming like an opposite alignment. Here this R is on this side. Here this R is going down. Can you see? Yes, this kind of opposite kind of arrangement is being made to make a balance. Okay? Yes. Yes, Arunima. So this is what is called as the trans. Okay, so it is not cis. It is going to be trans. It is all for the steric balance. Yes, Reshmi. Absolutely. So it is opposite means that it is going to be a trans, and it is all for your steric things. Got it? So this is understandable? Okay. Fantastic. So it is planar in nature. It is going to be trans in nature, and Cn is very rigid, and C alpha C, C alpha N, it is what it is contributing to your pi and the psi angles. Yes? Okay, fantastic. Right, good. So majority of the time it will be in the trans bond. Very few times it can come in the cis. So cis means who is going to make it in the cis? It is going to be our proline residue. Proline alone will come in the cis. All other residue it will be in the trans only. Okay. So Ramachandran, at first he gave the plot for your L-alanine residue. Do you know how long was this alanine residue that he took? It was just a dipeptide. Okay. So it is just a dipeptide. Dipeptide means two alanine residues, they were joined by the peptide bond and they were meshed. That's all. So your Ramachandran plot is applicable even for the shortest peptide. And you know, he used only the L-alanine. He didn't use this D-alanine. He used only the L-alanine for this purpose, and this is applicable even for the shortest peptide because he did with L-alanine dipeptide. Got it? Right? Okay, fantastic. Good. So now if you see this Ramachandran plot, you can see that the graph is being made between two angles. One, it is going to be the pi angle, and other one is going to be the psi angle. Got it? It is going to be the pi angle as well as the psi angle. So who is on the x-axis? X-axis it is going to be the pi. Who is in the y-axis? It is going to be the psi. Please remember this. So in the x-axis you will be having the pi. Okay, and in the y-axis you will be having the psi. Okay, y psi. Okay, right. X is pi. Remember this. Now you can see that there are different coloration. This is dark blue. This is little bit light blue. This is still more light. This is white. So what are these colors telling us? Is this telling something else important? Is it conveying to us something else? Exactly. It is telling us something. What it is telling? If the color is very dark, it shows that it is highly stable, or it is going to be theoretically it is favorable. Okay, right. This is little bit less. This is little bit less. This you can call it as highly unfavorable. This is going to be totally unfavorable. But these are all little bit favorable, guys. Got it? So now it is thorough to you regarding the coloration. Okay. And only one exemption, it is the glycine. Glycine can be found anywhere. It is not going to make an issue. Do you know why? Glycine, it has no steric hindrance. Why? Very small molecule, aliphatic, non-polar, and it is achiral. So anywhere the glycine can be found, even if it is going to be a white region also, glycine can be found anywhere. But you restrict one amino acid. Yes, Pankaj. But you restrict one amino acid. Which is the restricted amino acid? It is going to be the proline. Proline is the notorious filler. You don't want the proline anywhere in your plot. Okay, right. So what is this color indicating? The darker color is indicating that it is going to be highly stable. The light color is indicating that it is becoming a little bit steric hindrance is there. White, you don't prefer them. Right? Fine. So there are few conformations that are very, very common. It is going to include the alpha helix. It is going to include the beta sheet as well as the loop. Okay, these are the famous conformations that is usually present. And also the beta turns, they are also very, very common. So if you take the alpha helix, this alpha helix is very important, and there are going to be few amino acids which serves as an alpha helix former. Okay, and few residues it will serve as a alpha helix breaker. Okay, right. Alpha helix former, it is going to be this malic. Okay, or you call it as a maric also fine. And alpha helix breaker, it is going to be the proline and glycine. Okay, so if at all you are having methionine, alanine and arginine and leucine and your glutamic acid and lysine, they are all going to be alpha helix formers. But proline and glycine are going to serve as an alpha helix breaker. Okay, and also if at all you are having long blots of glutamic acid, then same charge they are going to repel each other. So if it is going to have a same charge, it is all negative, 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 it is going to repel each other. Okay, and if at all there is going to be a many adjacent lysine and arginine, they will repel each other. It should not contain any bulk shape. It will not form positive. And the proline residues, it will destabilize. So even that is not good. Your glycine residues, it will be very much flexible. Yes, so they are not good formers. Got it? So what are the conditions? Number one, there should not, if at all you want to make a good alpha helix, yes, there should not be any proline. There should not be any glycine. Okay, no proline, no glycine. Apart from that, it should not have no bulk residues. Okay, bulk residues should not be present at all. And then what else they should not have? They should not have any bulk residues, no glycine, no proline, and then they should not have what kind of other things? Long chain. Okay, it should not have long chain of aspartic acid, or long chain of glutamic acid, or lysine or arginine. Should not have a long chain, continuous chain. Then it is going to be a major flaw. Okay, so this is what is going to be the helix breakers. Okay, so these are the helix breakers, so you should avoid them such that you will form the good helix. Got it? Yes? Okay, fine. So this is how your beta sheet will look like. It may have an anti-parallel look, or it may have a parallel look. Okay, so these are the two kinds of beta sheet that is getting formed. Apart from that, there are beta turns. Beta sheet is different. This is what is called as turns. Okay, so where turns will be present? In parallel or anti-parallel? Where beta turns will be present? Beta turns, they are predominant with anti-parallel strand or parallel strand. See the diagram and let me know. Quick, everybody in the class. Come on all. It is going to be predominant only with the anti-parallel. Okay, beta turns, its location is very much predominant with the anti-parallel. It is not with the parallel, but it is going to be the anti-parallel only. Got it? Yes. Absolutely, it is good with the antiparallel. And seriously, this table is very, very important. It is going to tell us about the positioning and the location. This is the heart of our Ramachandran plot. Definitely take time to memorize it. Okay. If it is going to be an alpha helix, it is minus, minus. If it is going to be a beta sheet, it is going to be minus and plus. Okay, if it is beta turn, type 1 and type 2, it is going to be different. Okay, so first we will learn it from the box. Okay, and then again we will come to it. So don't worry now. Okay, we will first do a little bit learning and then again we will come back to it. Okay, right. So before that we will learn what is this type 1 turn. Okay, right. So this type 1 turn, it is formed between the residues 1, 2, 3, 4. Especially in this anti-parallel stance, you have this beta turn, and as far as your type 1 turn is considered, the second residue, it is going to be proline. So this type 1 turn, it will contain the second residue to be proline. Okay, usually second and third, they are going to form the turns. Okay, and what is the second? It is going to be the proline. In type 2, what is the third residue? Third residue, it is going to be the glycine. In type 2, the third residue, it is going to be the glycine. Okay, so you have two types of turn. One, it is going to be type 1 and other one is going to be the type 2 turn. In case of your type 1 turn, the residue number 2, it is going to be proline. In type 2, the residue number 3, it is going to be the glycine. So this is what is going to make up the turns. Got it? Yes? Okay. Now comes the next important diagram of a Ramachandran plot. If at all you are able to remember that chart and this diagram, absolutely you are done with the Ramachandran plot. Okay. Agreed everybody? Yes? Understood? Fantastic. Come on. So now we have a little bit small clue to remember this. Okay. So always psi will be on the left and pi is going to lie down and it is going to be ba, ba, la, ra. This is the simple clue. What is the clue? Ba, la, ra. What is ba? Ba is nothing but the beta sheet. Both your anti-parallel and parallel beta sheet. Collagen triple helix is also lying in this region, but the top left corner, upper left, it is going to be ba. What is la? La is going to be left-handed alpha helix. What is la? La is left-handed alpha helix. It is la. This is ra, right-handed alpha helix. This is empty. So ba, la, ra. Okay. So one more time, shall we just try this out? Everybody in the class, very, very easy only. So which angle will be at the x-axis? Pi or psi? On the x-axis, you have to have the pi angle. Pi angle should be in the x-axis. Who will be in the y-axis? It is going to be the psi angle. So now you split them into 4. So what is the clue? It is going to be the ba, la, ra. Ba means it is going to be beta sheet anti-parallel as well as parallel and collagen triple helix. This is going to be left-handed alpha helix. This is right-handed alpha helix. So pi, it is going to be negative, 0, positive. This psi is going to be negative, 0 and positive. Okay. So now is it easy for you to find out? So if it is going to be a beta sheet, the pi is going to be negative, psi is going to be positive. Got it? Is it now clear to you how to find out the charges? Negative and positive. So here it is both positive. Here it is both negative. This is also negative. This is also negative. Okay. If it is negative and negative, it is right-handed alpha helix. It is both positive. It is left-handed alpha helix. If one is negative, one is positive, it becomes your beta sheet. Got it? Yes? This one nobody is there. Is it easy or not? Come on everybody. It's a very, very important and fantastic aspect of our Ramachandran plot, which you are expected to learn. You should never forget this. Balara, you will not forget, no? Everybody, whenever it is coming in the exams also, you will remember it. Yes? So almost we are done with the concept now. So everybody is now ready to take their questions. Shall we all do the questions? Shall we all check how is our understanding? Okay, come on everybody. The first question of the day. Which one of the following statement on the protein conformation is not true? Yes, Ramprabha. Dihedral angles of the side chains in the amino acids are depicted in the Ramachandran plot. True or false? What about the first option? Dihedral angles of side chains in the amino acids, they are depicted in the Ramachandran plot. Will you call it as a true statement, or will you think that it is a false statement? Yes, Ram, it is going to be a false statement. Why it is false? Yes, Arunima. Why do you think that it is a false statement? Because it says that it is the dihedral angle of the side chain. Not at all true. Yes, Sonia. It should have been for the main chain. No. It is never for the side chain. It is only for the main chain. Okay. Right. Yes. Yes, Amrita. Very good morning. Fantastic. So see here, IR can be used to find the hydrogen bonding. Absolutely. IR is going to be, yes Ram, IR is going to be for your primary structure. So definitely all the bonding can be deducted. The three-dimensional structure till 100 amino acids, they can be measured by your NMR. Correct? If it is greater only, you have to use your X-ray. But if it is going to be lesser, you can use the NMR. Globular proteins, they have both your alpha helix and beta sheets. Yes, they can have, nothing wrong in it. So only incorrect option is meant for the side chain is wrong. It should be only the main chain. Okay, so shall we make up a move towards the next question? Yes? Okay, fantastic everybody. Come on all. So let us make up a move towards the next question in the Ramachandran plot. Given below or the statements, this was one CSIR much famous topic. Okay. So given below statements are related to the protein structures. Okay, right. So they are related with the protein structure. Okay. So let us see what are being given now. Right. Okay. So now you can see that yes, the dihedral angles of the amino acid X that is present within acetyl X N-methyl amide, it is occurring in a very, very small but equal areas in the left and the right quadrants. It can be concluded that X is not one of the 20 coded amino acids. Okay, right. The next option says that the dihedral angles of your 20 residue peptides, it is represented in Ramachandran plot. It is possible to conclude that your peptide does not have any proline. Ramachandran is not for sequencing. Have it in a corner of your mind. Two proteins, they have a similar fold. Okay, even if they do not share any significant similarity in the primary structure. Only on denaturation of a protein by urea, yes, the interaction that would be disrupted is ionic bond and van der Waals bond, but it is not the disulfide bond. Who will break the disulfide bond? Only your beta mercapto ethanol can break the disulfide bond. So definitely this is correct. So they are asking with all correct, which will be the correct answer? Yes, Amrita? Yeah, so B, it is not at all possible. So A, C, D with option B, absolutely it is going to be correct. Okay, so your dihedral angles, it occur equally in both right and left. Okay, so it is definitely not our 20 amino acid, it is an unusual amino acid. So it is all the other points are correct, but B is only the wrong answer. Okay, so A, C, D becomes correct. Okay, which of the following is true? Which of the following is going to be a true? Peptides that are unstructured it will have all the backbone angles in the disallowed region. It is not possible to conclude whether a peptide entirely adopts helix or beta sheet. The occurrence of beta conformation in a peptide can be deduced. The sequence can be deduced. Which can be the correct answer for this question? Yes, everybody. Yes, Amrita. Yes, Asht. Which is true, they are asking. I told you about the beta turn, isn't it? So, type 1 and type 2 beta turn. Yes, they have a specific bond angles. Okay, so definitely it is possible for you to find. Definitely it is possible for you to find out whether it is going to be your beta or not. See here, if it is type 1 beta, it is going to be minus 60 minus 30. If it is type 2 beta, it is going to be minus 60 and plus 120. So if it is going to be a beta turn, definitely it is possible for you to detect where is going to be this beta turn. Okay, so absolutely that is going to become a true statement. The occurrence of beta turn can be detected. Sequence, no way. Ramachandran plot and sequence are no way related. The peptides that are unstructured, it will be in the disallowed region. Nothing like that is proposed. It is not possible to conclude whether it is helix. See, if it is going to be entirely beta sheet, it will be present only in the upper left. Correct? If it is entirely right-handed alpha or left-handed alpha, it will be present here. So accordingly you can predict. So it says that it is not possible to predict, it is wrong. So only correct answer is option C. Got it, everybody? So now it is clear. Shall we make up a move towards the next important question? Yeah? Okay. So the following are 4 statements on the peptide and the protein conformation. Glycine. It has the largest area of conformationally allowed space. We saw this point. Glycine, it has the largest area of allowed space in the Ramachandran plot. A 20 residue peptide that is acetylated at N terminus and it is going to be amidated at the C terminus. It has this value minus 60 and plus minus 30. So both are minus means what is the conformation? If both are minus. This is going to be the pi angle. This is going to be the psi angle. This is in between. So this is minus plus. This is minus plus. So both are minus means it should be Ra. Ra means right-handed alpha helix. It is here shown as helix turn stand. So think whether it is going to be true or false. Okay. It is not valid for short peptides. Think. Okay. So this acetyl A1, A2, A3, A4 and CONH2, it adopts a good beta turn. So this dihedral angles of your A2 and A3, they will determine the type of this beta turn. So among them, which is going to be the correct? Yes, everybody. Yes. Very good. Option C, 1 and 4. This is not a true statement. I told Ramachandran did it for your dipeptide. So that is the shortest ever peptide available. So this is also wrong. So 1 and 4 with option C is going to be the correct answer. Okay. So shall we make a move towards the next question? Everybody is ready for the next question. Come on guys. In a 30 residue peptide, the dihedral angle pi and psi, they have been determined by one or more methods. When their values are examined in the Ramachandran plot, it is, yes Ash, not possible for the pi and the psi values to be distributed in the helix as well as in the beta region. It is possible that the phi and the psi values are all in the helical region, although CD spectrum is showing that they have a beta. Possible to conclude that the peptide is composed of entirely D amino acid. It is not possible to conclude if the peptide is helical or in beta sheet, which is correct. Once ready, let me know. Yes, Amanda. What about your D amino acids? Yes, Ramprabha. So D amino acids are like mirror. Okay, you can make it just opposite. So in your normal condition, this is going to be Ba, this is going to be La and then Ra. This is for your L amino acid. D amino acid, it is exactly just the opposite. Okay, so if it is going to be this one, it will become your lower right. This is going to be Ba. Lower right. This La will come down, this Ra will go up. Okay, so this is going to be lower left. This is going to be your upper right. Got it? So this is how they manage, if at all it is there. So the area of the allowed region in the Ramachandran map will be least for whom? The area of the allowed region will be least for whom? Least for proline. You don't want proline, no. So that is why that is going to be very, very least. Yes, Amita. Glycine is maximum. Proline is the least. Which one of the statements, yes Ash, which one of the statements on the protein conformation that is detailed below is incorrect? L amino acids, they can occur in this type 1 beta turns where your pi and the sigma, they are both positive. Peptide rich in proline is unlikely to adapt an alpha helical structure. Proline, they have high propensity to occur in this beta turn. This dihedral angles of the amino acids in unfolded proteins are exclusively positive. See what and all options they give for you. Got it or what? Done? Which option is correct? Yes, everybody, come on, think, ma. I couldn't read your comments. I'm waiting. Very good. Yes, Ansh. Amrita. Yeah, D is absolutely going to be incorrect. Okay. You cannot say that they will be always positive. There is no correlation. Okay. So, shall we go to the next question? Everybody, come on, cheer up. Yes. So the next question is seriously a very, very important one. Shall we see that? Okay. The structure of a protein with 100 residues, it was determined at this X-ray analysis at your atomic resolution, and NMR, the following observations were made. The dihedral angles, they are going to be determined from the X-ray structure, and NMR, it is going to be identical. The dihedral angles, it is going to, from the X-ray, it is going to be more accurate. The beta turns can be determined only by the NMR. Beta sheets can be accurately determined from the X-ray structure, which is with all correct options. Done or what? Yes, Ramprabha. Which question, ma? Please type it. I'll explain one more time. Yes, Amrita. Yes, Ash. Yes, Ramprabha. Correct. Come on, come on. Think, not B. It is D. Oh, sorry, BB. Yes, yes. Sorry, guys. It is B only. Correct. Incorrect. We will do that. Okay. So it is going to be, yeah. So it will be identical. It need not be the identical one. Okay. So X-ray is more accurate. Yes. And beta turns, it can be identified by both, and more determined by your X-ray. So 2 and 4 is, 2 and 4 with option B is the correct answer. So see here, L amino acids, it can occur in type 1 beta turns. Absolutely correct. Always L amino acids will occur. Proline is a helix breaker, so it will not be found in your alpha helix structure. Proline, it has a high propensity for beta turn. So all these are correct. Which is incorrect? It says that if your alpha and your omega thing of your unfolded proteins, it is going to be exclusively positive. Can it be exclusively positive? Not at all, no. That is why you have 4 quadrants. Else you could have only positive quadrant. Isn't it? Only positive means beta will only be there. This is negative, this is negative, positive, this is going to be positive. Yes. Got it now? Yes, Ramprabha? Yes. Yes. The beta turn, it is going to be positive. I'll show you. In case of your type 2, you can see that it is going to become positive. Okay. If it is iterated, it is going to become positive. Okay. Right. And among them, this one, it says that unfolded means exclusively it will be positive. You cannot say that if it is unfolded, it may be alpha, beta, anything. You cannot say that it will be exclusively positive. So that is why this is not going to come. Understood? Yes, Ramprabha? Yes, Amrita? Which PVQ you want? Yes, Amrita, this question. Which question you want? Just give me a hint, I'll explain it one more time. I got your doubt, Ram. Amrita, which question you want? Yes, Ram. Good. What about Amrita's doubt? I'm waiting for Amrita's response. All. Why? You didn't get it. See here, which is going to be the least region I asked. Okay. So least means it is having a steric hindrance. Okay. If it is going to be least, it is having a steric hindrance. Okay. So who among them who is having a steric hindrance? It is going to be the L-proline. Proline is only having the hindrance. That is why this is correct answer. Okay. Right. So which will be the maximum allowed fellow? Who will be the maximum allowed amino acid? Can you guess it? Yes, Vaiki. So which is the maximum allowed? It is going to be the glycine. Minimum is proline, maximum is glycine. Okay, this question just I explained you. And here this dihedral angles of X-ray it is quite advanced. Okay. So X-ray it is going to be quite advanced. Okay. And NMR is quite a trailing. Okay. So it is not as good as, see, you take a image in your normal mobile and you take in some high quality mobile. So which image will be better? If you take it in a high quality mobile, it is going to be better, isn't it? So likewise your X-ray is advanced. So it gives a better structure, better accuracy, better precision as compared to your NMR. NMR is like very, very normal experiment. Okay. So you cannot say that these two are identical. You can never say that. This dihedral angles from this X-ray, it is very, very accurate. Exactly correct. X-ray is very accurate. Beta turns can be determined only by NMR. Can you say that only it is NMR? No, I told you that X-ray is far better. So it cannot be only by NMR, eliminated. Beta sheets, accurately it is by X-ray. Correct. So 2 and 4 answer B is going to be correct for this question. Got it, Amrita? Now it is understandable? Yes? Why we eliminated 1 and 3 and how we took this 2 and 4 option? Yes? Okay, fine. Yes. Alright, good. So the next question we will do. The following, it is the 4 statements on the peptide or the protein conformation. Okay, right. So we'll go statement by statement. The first statement says that glycine, it has the largest area of conformationally allowed space in the Ramachandran plot. True or false? Glycine, it has the largest area. True or false? Come on everybody. Glycine is having the largest area. True or false? Absolutely. Very good, Arnima. Yes, Ansh. Yes, Tazeen. Fantastic. It is a true statement. Only proline is restricted. Yes, Amrita. And glycine is most. So it is a true statement. Next point. The 20 residue peptide, which is acetylated at N terminus. Acetylated means it is having an acetyl group. Okay, so acetyl group is added to this N terminus. Acetylated at the N terminus. It is amidated at the C terminus. It has -60 and -30. So, see, this is going to be your pi angle. This is going to be your psi angle. This is minus. This is plus minus. This is going to be plus. This is going to be, this is going to be minus plus. This is going to be plus. Now, if it is minus, what should come here? What should come here? Make it fast. This is ra. Correct. So, minus means it should be left-handed alpha helix, isn't it? Right, but it is given as helix turn strand. So the statement is true or false? Be quick, we don't have much time. Fastly we'll revise. It is going to be a false statement. So wherever you see 2, you can eliminate it, and you know 1 is correct, so definitely C becomes the answer. Got it? Anyhow, the allowed values is not valid for short peptide. Wrong. Because Ramachandran, he did it, yes, only for the dipeptide. Dipeptide is the shortest ever peptide. Okay. So that is why this is going to be no. Yeah. So this is going to be a false statement. And here beta turn, it is between 2 and 3. That is going to be correct only. Yes, so if it's type 1 and type 2 beta turn, we saw that type 2 it is having 2 as a proline and 3 is having 3 as a glycine. That's all. Okay, right? Absolutely. Fine. So this exact backbone dihedral angle in a folded protein can be obtained by deconvolution of its CD spectrum at different pH and temperature. You estimate the number of protons that exchange with deuterium. You treat them with D2O. My God. You want the exact backbone dihedral angle. So which experiment you will perform? Forming the fibers and analyzing the pattern. You analyze the X-ray diffraction and you find out the structure. Which is the best method? Among these 4, which is going to be the best ever method that is available? That is the question. Simple one, right? Yes, everybody, come on. Fantastic, Ramprabha. Good. I told you X-ray is the good method for measuring your dihedral angles. 4 marks for this question, believe me. Yes, yes, Arunima. Fantastic. So D is the answer. Yes, Tastin, absolutely. What do you think is right? D is the correct answer. Yes, Amrita, D is the correct answer. Got it, everybody? Yes? Okay, fantastic, guys. Alright, so like this you have several questions to do with, and this will be our final question of the day. Okay, right. So this is the pi angle and this is going to be your psi angle. Okay, right. Now you are going to find what is x, what is y and what is z. Make it fast. Yes, Amrita. Make it fast everybody. What is x, y and z? Y is down, so it should be the correct one. Fantastic. Balara, isn't it? So x is beta. And what is y? Y is right-handed. Okay. So y is right-handed. And what is ra? La, it is going to be your z. C is going to be the correct answer, ma. Okay. So we learned balara. See, x, y, z is swapped. Okay. So which is the correct answer? C is going to be the correct answer for this question. Got it, everybody in the class? Yes. It is all now clear to you, thorough to you. So many PYQs have come in the past. Okay. Yes, everybody. Absolutely. Yes, that's it. So one more final question we will do. Okay. See this. C alpha C. And then C alpha N. C N. Okay. And then it is C alpha R. This is W, X, Y and Z. What are the bond angles called as? C alpha C. What do you call them as? Make it fast, make it fast. Simple questions only they asked from the Ramachandran Plot. Not complicated ones. Very, very direct, pointed and simple ones only they ask. Come on, guys. Sure, Arnima, I'll tell you at the end. See, type 1 turn, okay, it will have the second residue as a proline, okay, and the bond angles are different. I'll show you the bond angles in this moment. And second, it will have third residue as a glycine. Usually between 2 and 3, the bond is formed in a beta turn, okay, and this bond angles I'll show you in a moment, okay, so after this question. Got it, Arnima? Okay, so what is C alpha C? It is very boring, psi, isn't it? Yes. And what is going to be your C alpha N? It is the cute pi. Okay. Right. And Cn it is going to be the omega. And the psi angle, it is going to be your C and R. So P should be 1 and Q should be 3. Yes, P1, Q3. R should be 4 and S should be 2. So option B is going to be the correct answer. Fantastic. Yes, Amrita, Ram Prabha. Very good, everybody. So that's all, folks, for today. I am taking up a very detailed course on biochemistry. If at all you are interested, you can come up for the subscription. You can use my code Saranya Live to get off some discount. Till 30th of April, we have a 20% off on the total fees. So don't miss out. Enroll at the earliest and get the edge of the preparation. Alright? Yes, everybody? Okay, fantastic all. So happy. I'll catch you all up in another interesting session. So take care till we meet. Yes, absolutely. I'm super excited to meet you all in a 3 p.m. session. In 3 p.m. you are going to work out with the numericals for your CSIR NET. Alright? Okay, everybody.